All right, so far we've talked about area of just 2D shapes, and we said that area was how many squares that we could fit into that shape, like square units, whether it be square feet, square inches, squared centimeters. And then we moved on to surface area, where we started about 3D shapes, and surface area was basically how many squares can you wrap around on the outside of that 3D shape, or if you're going to wrap it in wrapping paper, how much wrapping paper would you need exactly if there were no folds or overlaps in your wrapping paper. Now we're going to talk about volume of three-dimensional figures. Now what volume actually means is how many cubes can we fit into a shape. Even if sometimes we have to cut that cube up into tiny pieces or melt that cube into a liquid so it fills that surface totally up. And so the most basic shape that we can start off with here is a rectangular prism, and see how many cubes that we can fit in it, whole cubes or fractions of a cube. And to kind of give you a visualization of how prisms work, I'm going to start you with a rectangular prism that's 4 by 5 by 5. So the base is a 4 by 5 rectangle. And first, just figure out what the first layer, how many cubes would fit in that first layer there. So on this manipulative, in this site, it's a Geogebra website. The link is posted in your this week's resources, so go there, click on that, and you can actually play around with this yourself. But as we add right here underneath the green section here, if we add to that, it adds another block in there for us next to the purple one in there. So if I keep adding, you can see that the length is how many blocks we can fit in it lengthwise. So the length was 5, we could fit 5 blocks in it along that row. Then if we start adding rows of that dimension, go to the blue slider right here and add there. And we notice that the width is how many rows that you can fit in of 5. And you can actually go beyond the shape written there, but you're going to mess up your volume if you do that. So I'm going to take that one back too. So the very base right here is a 4 by 5. And 4 times 5 is 20. So we fit 20 cubes in there. And those 20 cubes, it's 4 by 5 by 1 high. And if you were to add, say, another row, currently this is like the volume of, instead of being 5 high, this rectangular prism, it's only 1 high. So it's a 4 by 5 by 1. If we double the height and make it a 4 by 5 by 2, it would look like this. I could add another one on. Let's take it down one. So we've added now another basically sheet of 4 by 5 on there, or another 20 cubes to it, and makes the volume 40. If we make it a 4 by 5 by 3, you're adding another sheet there, and you get 60. If it's 4 high, you end up with 80. And if it's 5 high, you end up with 100 cubic units there. So I don't want my students just to know that it's, you multiply 4 times 5 times 5, you could and get 100, and that's fine to know to get the volume quickly. But what I really want you to understand is the volume of a prism is just the area of the base times the height. If you add another unit to the height, you end up with one that's 6 high, or 120 cubic units, and so forth. So it's the area of the base times the height, and it doesn't matter if it's say a triangular prism. So let me pull up a triangular prism here. And here we have a GeoGebra resource again. I'll include that link in this week's resources. And for this one, notice the base is a triangle. And so the triangle is has a height of 4 and a base of 3 for itself. And so the area of that triangle is 4 times 3 times a half, or just 6 when you do that. So the area of that green triangle, that's a half. And then if you times it, no, not a half, it's 6. If you times that by the length of it, you're going to get 60. 10 times 6 is 60, and that's our volume there. So you can actually look at this link, and you can play around and get different triangles here and calculate different volumes and check your answer if you want to. But what I want you to know on all of these is the area of the base times the height. Let's look at the formula sheet that I mentioned in the last video. If we look at some prisms here, now the way this formula sheet's written out, it says volume is big B times H. That big B right there means the area of the base. So if you go down and look at our key here, big B means area of the base. The little b means just like, you know, the 2D shapes base, like the base of a triangle or the base of a trapezoid. So you'll see up here, if they're talking about something like a trapezoid, little b stands for this base. You have little b1 and little b2. For this parallelogram, they've got little b standing for that base. For the triangle, they have little b standing for that base. But when you get into 3D figures, big B means the area of the base. And so like with the surface area, you've got the lateral area, HP, times 2 big B right there. So big B is the area of the base. That gives you the lateral area. But for the volume, look at the volume right there. It's the area of the base times the height. That's what it is for a prism. You can even say the same thing right here. It is a rectangular prism. Area of the base is length times width. That's all it is, big B right there, times H. Now, the cool thing about this is it works for a cylinder also. Look at the volume equation. The volume equation is pi r squared times H. Well, what is pi r squared equal to? Look, pi r squared is the area of a circle. So to find the volume of a cylinder, you're just going to do pi r squared times H, and you have your volume there. Now, some other shapes here to look at. A sphere, the volume is 4/3 pi r cubed. There's not a whole lot I can do there. If you looked at the last lesson, we looked at how to find the surface area by peeling an orange, cutting it up, and putting into how many circles there to get 4 circles, so it's 4 pi r squared. Not a whole lot I can do with volume yet. If you got some ideas, let me know. I'm always willing to learn from my students as well. But at some point, I do have to say, okay, this one we're just going to go, here's your volume. It's 4 pi r cubed divided by 3 there. So that you're just going to have to reference the formula sheet for. But the prisms are pretty simple. You know, there's a lot of different prisms I can give you, because a prism is just any old polygon with rectangles for the sides there. So you take the area of whatever that base is, times it by the height. Cylinder, same thing. It's just that the base is a circle and not a polygon. So the area of the circle times the height. And then that's going to get us to the volume of cones and pyramids, which is there's a really fun activity to do. And I want you to look. I'm going to post a link to that. It's going to be a separate video. So you watch the video. It's an activity I do in class to figure out the volume of cones and pyramids. So that's pretty much it. That's what volume is going to be. Remember, if it's something like a sphere, we're actually taking those cubes and we're dicing them up. We're basically putting them in a blender and turning it into a liquid and filling it up, see how many cubes we can fit in that. Just like when we talked about the area, we were dicing up squares and putting them into the circle there to see what the area is. So it's pretty straightforward. I want you to watch the other video on finding cone and pyramid volumes, because it's a really cool activity that you could do if you're a teacher. If you're not, as a student, I want you to predict, basically the way it works is, without looking at the formulas, here, don't look at the formulas right now. So if I had a cone and I filled it up with water, and this cone had the same height and the same base as this cylinder, how many of these cones would fit into that cylinder? And that's what we do in my class. I've got a cone and a cylinder that are the same height and same base, and I fill the cone up with water and say, how many times can I pour this water into the cylinder? And let students guess. And sometimes I use water, sometimes I use rice. I've seen people use popcorn kernels. And the cool thing is it works just the same to do with a pyramid. If I had a pyramid and a prism with the same height and same base, how many pyramids would fill up that prism? So watch that separate video and then complete your homework. All right, let me know if you have any questions. I know this is a shorter video than usual, but I think that most of you will get it. If you don't, I'll be happy to meet with you or make another one if you need to follow up with some examples. Okay? Make sure that you put your units in there. So your units should be cubic units. All your answers should be feet cubed, miles cubed, whatever the units are cubed. And let me know if you have any questions. Thanks for watching, and have a great day.